All right, it's recording. Thank you.
Have you been, sir?
I'm good, thank you. Let's go. So, let's recap on what we've been doing so far. Calculus. I'm just on the right side. You don't have to write this down. It's just trying to put a bigger picture for you. Calculus is the study of gradients. Okay, literally. Everything that you understand about gradients in Year 9 is what we're doing. There were two parts to gradients. Year 9, you learned to find a gradient with how many points? How many points? Can I please have Namafi? How many points did you need to find a gradient back in Year 9? 2. So with 2 points. Calculus is the study of a gradient, specifically gradient of a tangent line. Tangent line means that it is going to touch the curve once. So that means there's only 1 point. So it's a gradient of the tangent line with only 1 point. And that's the key. That's pretty much what calculus is. It's the study of the gradient of the tangent line at 1 point of any curve. So, for example, if you had a exponential curve, so it looks like this, then I would have at this point, say at x equals 1, there must be a line that touches that curve exactly once. Okay? That line is y equals mx plus c, and that's called your tangent line. And your calculus rules essentially just gets you to do this. That's all you're finding. All these rules that you're learning is a shortcut to get to find the gradient at 1 point. How do you find the gradient at 1 point? Well, I gave you the theory. So I'm just going to write the exercise so you know which one was which again. So this was exercise 16C. Was it C or D? C. 16C. All right, that was gradient with 2 points. They call it average rate of change. And then the theory was 17A. That's called first principles. If you understood first principles, fantastic, because it's only required at year 11. Year 12, you don't need to learn how to do it. But by understanding the theory, it means you then understand why everything else is working. If you're doing specialist, you need to know the proof for each of those formulas. Then knowing your first principles is key. But if you're not, you don't worry about it, right? But the theory gives you a better understanding of what I mean by gradient of 2 points versus gradient at 1 point. Let's say you totally bombed out on what I said on the theory, but surely Year 9 stuff, Year 10 stuff, Year 11 stuff, you know how to find a gradient with 2 points. So that means 16C should be all right. Then I moved on from this. Instead of doing first principles, the theory takes too long to do to find a gradient at 1 point. So you are now learning rules. These rules will be on your formula sheet in your exam, both Year 11 and 12. But it's ideally that you know it off by heart. So the first rule that you learned was, what if the curve was not an exponential, but what if it was a power function? So meaning x to the power of something. So it could be x to the power of 2, x to the power of 3, x to the power of 99, or x to the power of a third. You could still use a rule for this. What was this rule called? That was the very first rule you learnt, which is in 17B. What was that rule called? Can I please have Christina? To find the derivative or the gradient of 1 point for any function that is a x to the power of n. Power rule. That's why it's easy to remember. Power rule was one of the first ones you learnt, which means if your function is ax to the power of n, the derivative, which we do a little dash on f, is, what is the rule? Let's go with Artie. What was the power rule again? So if ax to the power of n, then the rule gives you? Beautiful. That was the rule. That rule comes from the first principle. So someone out there, the mathematicians have already gone through that and they've been able to simplify it nicely to that, rather than you doing first principles in 17A. They've done it for you, right? I then showed you, well, not everything is always nice. X to the power of 3, x to the power of 4. You may encounter a problem that is still to the power of n, but instead, what's inside could be something like, I don't know, let's make it up. I'll do 3x to the power of negative a third plus 5x. that creates a bigger problem. That to the power of n now, this is much harder to do. The first one was easy. This one's harder. So there had to be another technique. What was the alternative technique that I taught you when you get this kind of problem, which is our last session? What was that called? Can I please have Anthony? Chain rule. Chain rule was about you finding a third variable, introducing a third variable, which in our case we call it u. So in the notes, in this particular notes on the very first page, we call this u. So we say let u equal to this entire problem. Then it becomes, let's say, 3x negative 1/3 plus 5x. Then it becomes u to the power of n is much easier to do than this one. So there was a rule to teach you how to do it. Chain rule was delta y delta x, which means the derivative, is delta y delta u times delta u delta x. If that you've forgotten, revise, because that was the first part of our session. But that's two rules that I've given you so far. So you either have a problem with just a function that's a power. You might have a function that has a power, but then it's convoluted, it's factorized. These two accommodate for that. What you're missing is this page today are the other functions. You are missing exponential, log, sine, cos, and tan. So together, there are 7 rules that you generally just need to memorize and understand. If you want to know the proof to it, there are proofs for all of them. You do not require to know the proofs for them. But if you want to know the proofs, it all comes from the first principles. And there are many videos and online that you can watch. It just probably will push you, unless your algebra is strong, then you can understand what they're doing. Okay? But it's not expected. It's just expected that you know the derivatives of each of these functions. So the shortcut for if I gave you y equals e to the x, then the derivative, delta y delta x, nicely is e to itself. Okay? But it's not the same for 2 to the x. 2 to the x is different. It has to be e to the x. Okay? Same thing with log. Log has to be a base e. If you find the derivative of log, delta y delta x will equal to 1 on x. If you have y equals sine of x, if that's your function, the derivative will equal to cos of x. The reason why I'm telling you these parts here, because we're going to use chain rule in conjunction with these ones. So you used chain rule with power rule before. We're now going to use chain rule with one of these 5 in these examples here, so you can see how I'm using these facts to help you use chain rule to solve these problems. So these are examinable. These are the type of questions you get that are examinable, not so much the first one. Back in 2010 it was. Back in 2010 it was chain rule and power rule, but the kids got better, so they've moved away from that. Even these ones don't usually come up anymore, but you still need to know how to do that. Okay? And the one that students tend to forget or not understand, if you've got y equals tan of x, the derivative, so delta y delta x, equals to the second squared. You may not know what the second is. Second is the same thing as 1 over cos. So unless you do special, then you're more familiar with that one. But second is 1 over cos of x. So when we say second squared, we just mean 1 over the cos of x all squared. Okay? So tan of x is one that students tend to forget at year 11, but afterwards, again, all of this is in your formula sheet for 11 and 12s. Always in that calculus section. You're going to refer to this page as I'm doing these examples down here. Okay, so we're going to do some examples so you get a feel of how chain rule works, and it revises chain rule as well as develop some extra rules. So over this holidays, that's what I want. I want you to, over the holidays, when you come back, I expect when I ask power rule, chain rule, or any of these derivatives of any of these functions, that you can respond. Because then I'm going to show you the applications to it. Like, how do you then apply that understanding? Okay, but you need to know that first. That's your prerequisite. Okay, let's do the first example. Let's do this one. I'll leave this one later because that's similar to one of the problems we did prior. You guys can have a go with this one later. But let's do B first. Let's have a look at B. All right. Let's have a look at B. So first thing, what's my function? Is it a power function? Is this a power function? Yes or no? Because out of your 7 rules, you need to be able to pick the right one. So out of 7 rules, which one do you pick for this question? If I want to find the derivative, meaning finding the gradient at one point, I need to be able to derive this first. So instead of doing first principles, they've given you a rule, but you've got 7 of them. Which one would you use first? Which one's this one? What's your first inkling? There is a part of a power rule in here, but if you look at the entire function, it starts off with cos. So this is the first thing that you have. That's a cos function. You have a quadratic function, so a power function within a cos function. So which rule should you be using? You should be using this one right here, number 4. Because that and this one look so similar, don't they? These two look almost the same. The only difference between the two is one is x, which is a linear. This one's x squared minus 1. See that? So they both start with a cos. They don't both start with an x squared. They both start with a cos. So this is the rule that we're going to use. So what do we know? So we know this. This is what we know. We know, had I been given y equals cos of x, this is the rule I want. What is the derivative if it was cos of x? Based on the rule I gave to you, what would it equal to? Look at the table. I've given it to you already. Negative sine x. Just on the table, very first page. Yeah, right there. I already said here. So cos of x, it says here, derivative, negative sine x. Yeah, so cos x, that's your function. The derivative is negative sine x. If your function is tan x, the derivative is secant squared. If your function is e to the x, derivative e to the x. Just follow the table. Yeah? So that is your function, that's the derivative. Function, derivative. Function, derivative. Function, derivative. Yeah? So this is what we know. If I had cos of x, then the derivative is negative sine of x. But do I have cos of x? No, I don't. I have cos of x squared minus 1. That's the problem. This is where chain rule comes in. When you have a problem and you've almost got it there, you introduce a third variable to make your life easier. This is why I said chain rule is your bread and butter. If you don't know how to do chain rule, it's like not knowing your times tables and trying to do fractions. Okay, you need to know your times tables to do fractions. You need to know chain rule to do calculus. Okay, so chain rule, this is an example of it. So we know it's cos of x. The problem is that x squared minus 1. So what do? This is what you do. Let's practice chain rule again. Chain rule was, we're going to replace this x squared minus 1. We're going to replace it and say, let u equal to x squared minus 1. So you introduce a third variable. So you didn't exist. We made up this letter. Okay, you could have used any letter. You could use P, T, whatever letter you like. But the point is, I'm replacing x squared minus 1 with the letter u. Now if you do that, that changes the problem. Instead of it being y equals to cos of x squared minus 1, it now becomes y equals cos of u. Because I've replaced x squared minus 1 with the letter u. This is much easier. Okay, so if I asked you now, what is the derivative delta y, so derivative change in y with respect to the change in u, because that's now u, not x anymore, then we can actually say, well, that means the rule is delta y, delta u should equal to, what is it equal to? Have a look. If it's cos x, derivative is negative sine x, then what if it's cos u? What's the derivative? Yeah, negative sign. It's just a change in the letter. Nothing crazy here, right? So, negative sine u. What's the chain rule again? Chain rule is on the very first page if you've forgotten it. We're trying to find delta y delta x. Not delta y delta u. Delta y delta x was equal to delta y delta u times delta u delta x. This is chain rule. This is the chain rule. That's why we introduced the variable u. Now we've got this one. This is what we've got. Delta y delta u was negative sine u. So we got this one. Where do we get delta u delta x? Where's that going to come from? So this is revision of yesterday, last session. Do you see an equation anywhere where it connects between the u and the x? Which equation are we looking at? U equals to x squared minus 1. So if you were to find the derivative now, same thing, delta u delta x, so it's a change in u with respect to x. That's nice. We can do this one. You guys said power rule before. That's true. This is a power function. So this is where you use power rule. It's an x squared. Derivative of x squared is what? Can I please have Milena? What's the derivative of x squared? 2x. Very good. Bring down the 2 and minus the power by 1. So 2 minus 1 is 1. So you get 2x. Very good. We got 2x. What's the derivative of negative 1? Phoenix. 0. Good. Remember, the derivative of any constant number is always 0. So now that we've got delta u delta x, we've got delta y delta u, you put them together. This is now negative sine of u multiplied to 2x. That really is just negative 2x sine. Now we don't leave it in terms of u, because the letter u was something I made up. U was equal to x squared minus 1, and we want y and x, not y and u. That was a made-up variable to help us do this derivative. So I need to leave my final answer as negative 2x. Negative 2x times the negative is negative 2x. Sine of u, use x squared minus 1. That's my answer. This is the derivative. So if you want to find the gradient of a cos graph, of cos of x squared minus 1, you just need to know now where on that graph do you want. At x equals 1, at x equals 2, you sub it in to find the gradient. But this is just a formula to find the gradient. That's what it is. Derivative is the gradient function. It just means it's a function of all the possible gradients you can have. You just don't know where x is yet. But as soon as you know where x is, you know what the gradient is. Okay, but the first skill is to get that. And you want to be able to do that, all this, usually in 2 steps. Okay, so by end of year 12 or end of this year, I want you to be able to do this step, both in your head, and you get to this point. Let's do another one. Here we go. Let's look at the next one. Same question. Out of your 7 rules, which one does this resemble the most? 3e to the power of sine x. Which rule should you be picking first? What's your template? So this one was cos. So your template was cos. What's the template here? Which one is it? Yeah, it's e to the power of x. This is the beginning. It's a sine x inside an exponential. So you need to be able to determine where is the problem. Where are you changing it? So here, the template should be y equals e to the x. Now, based on the rules I gave you, if the function's e to the x, what's the derivative? Yeah, it's the same itself. So this is ideal. This is what we want. But we don't have x. We've got sine of x. That's a problem. So what do? Same thing as before. We look at this and say, this is a problem. I wish it wasn't sine x. I just wish it was x. So what you do is you then do exactly the same. Let u equal to sine of x. If you do that, changes the equation to y equals, instead of 3e sine of x, it now becomes y equals 3e of u. That's a key step there. That's chain rule. Can you see that? All I did was just replace sine of x with the letter u. Now you got y in terms of u. Do the same thing as before. Delta y delta u. We've got 3 times. Now what's the derivative of e to the u? We know the derivative of e to the x. So what's the derivative of e to the u? Molly, thank you. What's the derivative of e to the u? So look at the template. So you got a template for a reason. What's the derivative? So if I asked you what's e to the u, derivative of e to the u, it should be e to the u. Same thing as itself. It's just the change in the letter. But funny enough, I do see a lot of students struggle at this step. It's like the e to the x, they're like, yeah. I say e to the u, they're like, nah. And I'm like, it's just a change in the letter. It's the same variable. There's nothing different about it. Yeah? So you got delta y delta u is 3 times e to the u. Fantastic. Means it's still the same as itself. But at least in the chain rule, we've got delta y delta u now. The thing I'm missing is I need a delta u delta x. That's going to come from the equation that has connection between u and x, which we did over here. Using your 7 rules, what is the derivative of sine of x? Look at your 7 rules. What's the derivative of sine of x? What does that equal to? Let's go with, who have I picked for a while? Mete. Cos of x. Chain rule says tie the 2 together. So here we go. Chain rule says delta y delta x, which is what we're trying to define, is equal to delta y delta u times delta u delta x. You found both of them? Write them down. 3eu times cos of x. But remember, we don't leave our answers with the letter u because u is made up and we're trying to find the change in y and change in x. So your answer is 3e sine of x times cos of x. And you stop there. That's the derivative. Just don't forget what the derivative means. Derivative just means it's the formula for you to find the gradient of a tangent at one point. You just don't know where the point is yet. You don't know where x is. That's why there's an x there. Okay, so this, at the end of the day, will allow you to find m. When you do applications, that's really the missing link that students have no idea what they're doing. They can do it derived, they can do it on the CAS, but they have no idea what that means. And that's why I keep honing back. It's to find the gradient with one point. You haven't been told where yet. You haven't been told which point. If you knew it was at x equals 1, then you just sub 1 in. And they'll tell you what the gradient is. That's what this formula is. By doing the derivative, it tells you the potential way to find a gradient. If you get that, then chapter 18 will be much easier to understand. That's the applications. Yeah? All right. Let's pick another one that could be, what's a different one that we can do? We'll do a log one. Let's do E. If you're wondering how to do these fractions here, that's index laws. That's just same base, cancel them out. So what I taught you in previous sessions, write e to the 2x divided by e to the x, e to the x divided by e to the x. If you've forgotten your index laws, like a reminder is like 3 to the power 5 times 3 to the power 2, most students will know how to do. Yeah, so whatever you're using there, whatever rules that you've memorized back in year 7, that's what you're doing here. Instead of 3, they've changed it to e. Instead of times, they've just changed it to divide. That's all it is. It's the same thing. Same rules back in year 7. Yeah? So question A and question D is simplifying by index laws. That's why I'm doing E. Okay, so we're going to jump to E. All right, let's have a look at E. What's the template? Out of your 7 rules, what's the template? Which one are we using? What's the main rule that you're seeing here? Because you have to be able to identify which rule. Which one is it? Yeah, it's log EX. Yeah, because we can see it's log E to begin with. And what am I substituting? It's this one. That's the problem. So, template is log e of x. What's the derivative based on the formulas I've given you? 1 of x. That would be the answer had this just been an x, but it's not an x. It's cos of x. So you replace it. That's what chain rule is. Chain rule is just saying, let's replace it. Replace cos of x. Here we go. Let u equal to cos of x. That changes your problem. Instead of y equals to log e of cos of x, you now have y equals log e of u. That is much easier to do. Okay, so I'm just going to move this to a side so I have a bit of space. And now I'm going to ask the same question. This is the third time I'm doing this. Delta y delta x. What is the derivative? If you know this is your template and you've replaced that cos of x with a u, what is the derivative of log e of u? What would it equal to? Yeah, just 1 on u. It's the same thing as before. It's just a different letter. Yeah, so it should be 1 on u. Now, we've got delta y delta, that's delta y delta u. We've got this one now, delta y delta u. We're just missing delta u delta x. How do you get that? We'll find the derivative of this. The thing that you made up. The connection between u and x. So delta u delta x. Go back to your 7 rules. What is the derivative of cos of x? Derivative of cos of x equals what? Look at the table. Yeah, negative sign. So in this case, it's negative sine of x. And you put them both together. Here we go, chain rule. Delta y delta x equals to delta y delta u times delta u delta x. Here we go. This now gives you 1 over u times negative sine of x. Well, we don't write u because u was something made up. So you replace it. It's 1 over cos of x times negative sine of x. Notice that's a fraction. So when you multiply numerator and denominator, it ends up being negative sine of x over cos of x. But we also know sine of x over cos of x is the same as what? Tan. If you've forgotten, tan is opposite of adjacent, or y over x, and that's the same thing as sine over cos. So you can write your answer as negative tan of x. But if you didn't see that, these two answers are okay. But I do know at year 12, they test that more often than the last few years. So in the last 4 or 5 years, if you just look at the past exams, you'll see a lot of this, because students struggle with that fraction. Yeah? But tan is very common. Is there a negative on the way? Did I forget something? Where? Oh, there was. Whoops. I didn't see that. Thank you. I didn't see the negative here, so it should have been negative at the front. That changes this one to be a negative. That means this is a negative. And then that means that's a negative. That's a negative. So double negatives become positive, so we can cancel that out. So it should just be tan of x. Thank you for picking up on my mistake. No, that's only if you derive it again, because we derived it already. This is the derivative answer. If it was to take this and derive that again, which is called the second derivative, then what you said is correct. How do we feel so far? So that to me is combining a couple things. You're learning all 6 rules, or technically 7 rules, and applying chain rule. Chain rule is the bread and butter. So the whole point of me designing these questions is so that you practice chain rule. And the sheet that I gave to you right here, this one has all of the rules for you to practice. What you are missing though, I haven't taught you product rule, that's for next term. But I do want everything else. Chain rule for any one of these power functions. Chain rule for any of these exponential functions. Chain rule for any of these sine cos functions. And then chain rule with any tan functions. That's what you practice. Answers are in the back. You can't do product rule yet. I haven't told you guys. So questions 1 to 3, you should be able to do. Unless you've learned the product rule. I used that ages ago. Now I've forgotten what it was to say. I'm probably with the boss. Straightforward. We have one. I remember when I was.
Yeah, but I was like, no. He has to move I don't know if then you literally have to teach
Alright, Tim, I'm going to stop the video. That's it for today's lesson.